Let's say you have a funny video and you want to publicly share it with others around the world. There's many ways you could go about sharing this video. Definitely the simplest way is to upload it to the web. You could upload it to YouTube, Instagram, TikTok, and many other websites. For example, let's say we upload the video to YouTube. Now to share with others, we would take the link to the video we uploaded and share the link perhaps through text, social media, email, and so on, and as long as others receive the link, they'll be able to use that link to access the video. This is because the link has a unique URL or Uniform Resource Locator. This link can take us to the video, or at least it can until the host decides to take it down, manipulate it, censor it, or even remove it. Perhaps the video hosting platform goes out of business one day, and the videos on the server are permanently lost. In reality, you are depending on this video platform to keep your videos hosted. We call this method of retrieving content online host-based addressing. But what if there was a way we could look up our video without host-based addressing and without relying on a centralized server to host our video? Well, that is what content addressing allows us to do. Content addressing utilizes hash functions. Similarly to how a hash function can generate a unique key for hash maps, hash sets, and similar data structures, we could generate a unique key that can serve as a replacement to a shareable URL. So we've solved the problem of accessing the video, or so it seems, but we still need to find a new way to host the video. That is where the IPFS, or Interplanetary File System, comes in. What we can do is take the video data, break it up into a collection of data chunks, and redistribute it to a bunch of individuals. Collectively, these individuals make up a network, not like the traditional web, but a decentralized network. But as we distribute these chunks to individuals in this decentralized network, we are left with a problem. We need to be able to eventually pull these relevant chunks of data back together to reassemble our video file. And to do this, we're definitely going to need some sort of references to these chunks. To accomplish this, the IPFS creates their equivalent of what we call a Unix FS file. An IPFS Unix FS file is a directed acyclic graph heavily inspired by a Merkle tree, which keeps these chunks connected and is used to represent a file object. It allows us to systematically organize our chunks and references to these chunks, similarly to a binary search tree. Let's imagine, again, we have a file with 800 megabytes, and each chunk is 100 megabytes. We can organize them similarly to a binary search tree, where the leaf nodes are 8 chunks of 100 megabytes. And now, because we have references to all of these chunks of data, each of these resulting chunks can be on different computers within the decentralized network. As a result, structuring these chunks as an IPFS Unix FS file helps us host and share our video without host-based addressing.